What are metrics? Metrics are events that's happening in your environment. Like CPU, what is the utilization of CPU? What is the utilization of memory across a recorded series of time, right? That's what is metrics is all about. Traces are basically your end user, like the flow of your end user journey, right? Like what are the different services the flow is navigating towards? What are the different dependencies? How is your flow looking like, right? So traces is fundamentally a very important signal that is going to tell us what's happening for each flow that's happening. So these are the three important events that can be emitted and can be used for observing your microservices environment. And then talking about instrumentation, there is the common question around what do I need to instrument? Why should I instrument is something we saw about, but what should I instrument? So the fundamental answer is you should instrument everything, right? Irrespective of what layers you're operating, like whether it's a front end or a back end or a mobile app or a browser app, or whether it's going to be your hosting environment, whether it's going to be the virtualized hardware on the cloud, it doesn't really matter, right? You should use instrumentation as a mechanism to instrument. So which means all the components in your infrastructure should be thoroughly instrumented. That's very important and fundamental for observability. And talking about instrumentation, we have seen some organizations say that, hey, why should I instrument? Is that an opt-in? I mean, should I have to set it up manually, right? So understand that instrumentation is not opt-in, which I already mentioned. But the thing about instrumentation is standardization of tools. Like using some kind of standards around instrumentation is really going to help you the process of setting up the tooling. I mean, across a standard way. Like one example is open telemetry. If you're going to use open telemetry, like AWS distro for open telemetry, you're going to have some standardization around open telemetry, which means it is going to standardize your instrumentation process, which means you don't need to use different tools to instrument, right? You can use one tool, which is basically acts as a mechanism to forward logs, metrics, and traces across different ecosystem of services, right? So fundamentally, what I'm trying to say here is instrumentation is not opt-in, and it should not be manual process. It should be an automated process. And the most important thing is standardization of tools to make it instrumentation common within the organization. And the next important thing I want to talk about is observability plan. What is an observability plan, right? Observability plan is not just collecting metrics and traces and let it go there. That is not observability plan. Observability plan is all about collecting data, collecting information from the data, using the knowledge from the data, derive insights out of the data, and what are the actions, like what is your call for action from the data. That is going to be the most important piece of an observability plan, right? An organization, say it is people, architects, like the different people from different parts of the organization, right? What are you going to do with the data, right? That is the most important thing. Like you have the insights, you have the telemetry data, you have the logs, you know what is the pattern of your compute performance, you know the pattern of the end user flow, you know the pattern of the logging aspect of you know the pattern around the calls that's happening, but what are you going to do with that? Are you going to really improve upon it? What is your call for action? That goes into the thoroughness of the observability plan, right? So what is the data you're deriving? So first of all, what data you want to derive? What is the data you're going to derive? And from there, what information you're going to gather? And from there, what is the knowledge you're going to get? What is the analytics you're going to get? And what are the insights that you're going to get from the data? And most important thing is, with that insights, what is your call for action? What are the things that you wanted to improve? What are the things that can promote business agility? What are the things that can help you move from the operational aspect into business agility aspect? So those are all the important things that goes into the observability plan. So which means that observability plan is not just for architects, or it is not just for SREs or developers. It is just for the whole organization, right? Even at the top of the house can use the observability signals and insights to make some important business decisions, right? So that's why it is very important to understand that observability is a plan that everybody comes in. It's not just the technical folks deal with. So that's what it's all about in terms of observability plan. The next, we want to talk about different observability options on how you can use AWS to architect the observability, and how you can use OpenTelemetry, how you can use instrumentation. So I'm going to hand it over to my colleague Munish, who's going to take it forward. Over to you, Munish.
Yeah, thank you, Ella. Yeah, so at AWS, we believe no one size fits all, and we believe in providing option to our customer to select the right tool for the job. So as you see on this diagram on the left-hand side, we have AWS native services, which center around Amazon CloudWatch. So we have an option to collect logs, metric, traces, three pillar, which Ella talked about. It provides us that unified view of logs, metric, and traces. For example, we have CloudWatch logs for the logs pillar, we have CloudWatch metrics for the metrics, and then we have AWS X-Ray, which complements them with the distributed tracing. And then you can use CloudWatch dashboard to get that centralized visibility into your workload. And then you have also have CloudWatch alarms, which you can use it for your alerting and incident notification. And it goes even beyond that. You can use, for example, CloudWatch Synthetic, where you can simulate a client for your API and endpoints. So on the right-hand side of this diagram, we have open source alternative. It addresses all the three pillars we talked about, and it focuses around, built around the services such as Amazon OpenSearch, Amazon Managed Prometheus, and Grafana. Customer can leverage OpenSearch to capture the logs. They can use the Managed Prometheus service for the metrics and OpenSearch tool such as Agar or Zipkin to capture the traces. You can also leverage OpenSearch to store traces as well. And you can also correlate the logs and traces. That can be very useful when you're really trying to figure out what's the root cause of the issue. And then you also have in the AWS distro of Open Telemetry, which is a secure and production-ready distribution for open source telemetry project. And you can use that to do the instrumentation. You can use that to collect the signals, like both metrics and traces are supported right now. And then you can use Amazon Managed Grafana to visualize all your observability data as a single pane of glass. So we want to give the customer option and flexibility, but the question is how they can choose the right tool. Ella, next slide. Yeah, so how and then next slide. It really boils down to your specific requirement and the use case end of the day. So here's some of the few criterias you can use to help make the right decision. So the first one I will say is complexity. CloudWatch is very easy to set up and it's serverless. You can use the CloudWatch agent is already installed on if you're using our EC2, Amazon Linux EC2, and it's already installed on ECS. So there's a very minimum configuration required. While for open source in general, you have to configure multiple tools, and the setup can require heavy lifting, but there's the ways, like we'll share later in the presentation, how you can remove that heavy lifting using some of the automation. But then it really boils down to two things, right? One is the simplicity. If you think you are an operational powerhouse, if you're not an operation powerhouse, then you want to just stick with the managed services, with the CloudWatch. And if you want that flexibility and customization, and you have this specific requirement, then you generally people end up choosing with open source compatible options. And our second one is the integration. With CloudWatch, it natively integrates with most of our managed services, so it just works without much heavy lifting. For open source observability, you have relatively fewer native AWS integration option, but you have a lot more integration available with third-party and open source tools. So really, depending on your use case and what kind of stack you have, if it requires, like for example, using Kubernetes and a lot of open source tools already, then you might want to pivot to the open source observability option. And the third one we've seen third can be useful is the hybrid workload. If you can use CloudWatch or X-Ray agent, it can be installed on-prem to capture logs, metrics, and traces. But we've seen with the customer, especially with the on-prem workload or hybrid or the other cloud providers, they prefer to use open source agents such as AWS Open Telemetry or Open Telemetry rather than using a vendor specific agent. And I will say other key factor not listed here is it's just also based on the existing tooling and how much effort required for when customers are trying to migrate from on-prem to the AWS, how much effort required. So if they require a lot of refactoring on there and they're already using, for example, OpenSearch or Prometheus, they would just like to use the similar option just in a managed service. Since they already teams are already familiar with it and they already have a framework around it. So that could be another way how customer can choose it. So let's say take a look at the reference architecture of the unified observability, leveraging the open source observability stacks. And I want to get your So here, really, this is a opinionated architecture you can use to build your observability platform and get the centralized insight. In practice, it can get a little bit more complicated because you want to capture your telemetry signal from workload running on EC2, AWS managed services, on-prem, and sometime other cloud provider. But this architecture is extensible without much heavy lifting. So you get the picture. And I'll talk a little bit more on how these all pieces fit. So, and we work with many customers where we deploy this reference architecture for their workload in AWS, roll it to thousands of VM, Kubernetes cluster, managed services, to just get that centralized insight across their siloed business units. And ideally, you want to also have a single dedicated observability account to capture all the telemetry as a best practice. And then we also have like features such as IAM role anywhere, which allow you to leverage the short-term security credential to connect to your AWS resources. So here, just want to talk about talking about the first box here where we have the EKS ECS cluster. High level, we start, as Ella mentioned, we start with the instrumentation. You want to make sure everything is instrumented to ensure our emit the log. Your application is an infrastructure is emitting the log metrics and traces. And then we can use a dot collector, which is the AWS of open telemetry, to gather the metrics and traces. Here in this architecture, we're using Fluent Boot to gather the logs. The logs are in alpha right now in the open telemetry, but eventually it'll be supported. So you can capture. Ella, can you move to the next slide? So I want to get your attention on the central box here. So once we gather all these metrics using a.collector, we can store them in the managed Prometheus service using a secure VPC endpoint. And then it's also like Amazon Managed Prometheus is a fully managed serverless offering. It's backed by our S3, which is simple storage service. So it's highly durable, and you can keep your metrics for much longer duration if that supports your use case. And then it's also spread across 3 availability zone to ensure the high availability you have, and it grows. This generally we've seen in the customer in the on-prem space, you know, just as the metrics grow over time, the storage becomes a big issue. So, but in the managed Prometheus, it automatically grows as your needs grows. And then you can use the ADOT collector to very easily point to the managed Prometheus. So all your network traffic stay within the backbone using VPC endpoint. Excuse me. For traces, customer have an option to either leverage OpenSearch or X-Ray. So we can store the logs in OpenSearch, and you can also perform with OpenSearch. You can also do anomaly detection, and you can also query the data. We'll see and in the right hand side, to visualize all this, we can use Amazon Managed Grafana. Ella, can you click next time?
And before we go to the next slide, we have a question. Are there resources for designing AM roles properly to provide short-term access? I think it's like basically, do we support short-term access via IAM roles for this architecture for all services? Because Stefan is still like mentioned that there is area where people struggling with to granting like proper permissions.
Yes. So as I kind of mentioned briefly there on the previous slide, so we have IAM role anywhere. Really, it's a feature of our IAM service where you can use that to use the short-term security credential, like very similar to how you do it on AWS. You can use the same role and policies, and I can share a lot more documentation on that as well.
That would be awesome. Thank you, Munish.
Yeah, and that's the best practice as you mentioned. You want to make sure, especially for the workload which are on-prem or other cloud provider, you want to use the short-term credential. Long-term credential is not encouraged, definitely. So we definitely encourage that. And then on the you can use the Grafana, which is a fully managed Amazon managed Grafana, which is a fully managed serverless offering, and it has native integration with many of the AWS services like Prometheus, OpenSearch, CloudWatch, Athena, and it has you can use the VPC endpoint for the enterprise ready security, and then it also supports all the enterprise ready like single sign-on and the SAML. It also supports that, and you can also get the centralized alarm and alerting. You can send it to multiple destinations, for example, PagerDuty, Slack, Opsgenie, and both Prometheus, managed Prometheus and Grafana Also integrate, you can use like, tools like Noble9, where you can define and implement and monitor your SLOs specific to your objectives, related to maybe health and performance of your service and infrastructure. So so you get that centralized visibility and you can monitor those SLO as well. But the question is how can customers can make these observability reusable and consistent? And that's one message we keep on hearing. We build it for one team, one platform. How we can reuse across these multiple teams, especially when you're running as the enterprise. Ella, can you plug in? Next. So answer is observability as code. You want to treat observability as code and automate just like you would treat your infrastructure and application. You want to version your observability stacks as a single source of truth in GitHub or other repositories. And doing so allow you to build that automated and repeatable asset. And once you develop these assets, for example, agent deployment, configuration, it could be Grafana dashboards or alerts, all that can be codified and it can be easily deployed and recreated in your different environments, maybe onboarding a different product, maybe you bought a new company. It just makes it very easy to share that once you have everything codified and stored. And then also, like, it also encourages the DevOps collaboration, especially, if your other teams, different teams can see what's in the Git repository, what dashboard they're using, so they don't have to restart from the scratch. People can leverage what they did and use those best practices and build on each other. So you can fine tune the alerts or dashboard with a simple pull request. So you really want to treat this whole observability stack as a product. Um, so all these sounds good, but how can you start with observability as code? Um, so one of the opinionated way we have is the open source solution we put together is the Observability Accelerator, AWS Observability Accelerator, where you can actually use the observability as code with a single command. It's a purpose-built and opinionated solution. It leverages managed Prometheus, Grafana, and AWS Drift OpenTelemetry, following all the best practices. So your SRE and DevOps team don't have to navigate and figure out how these different Lego pieces, AWS services connect to each other. You can just simply start with a AWS Observability Accelerator, and it can deploy the solution. Currently, we support EKS, but we're others. ECS is also on the roadmap. We're planning that. Next slide. And this diagram is pretty much like what you see here. It's very easy to start. This is the in the bottom here is the GitHub repository where you can you can go and see all the code is there for AWS Observability Accelerator. And very easy to deploy. You can just clone the GitHub repository and did the Terraform apply, and you'll all this infrastructure, all this architecture you see on the diagram here, we can provision it for you. For example, if you don't have EKS cluster, we can provision that one as well for you. If you already have one, then you can install the agent on it. We can configure the configuration for it. It can automatically remote write. If you don't have a managed Prometheus, we can also spin off that workspace for you as well. It can do also provide some curated recording rule and alerting rules. It can also write the traces to the X-ray and then also use the managed Grafana to visualize all these dashboards. So you get dashboard also out of the box for certain workloads. I highly recommend you take a look at it. And then again, it's open source. We're also looking for contribution. If you think if you have any specific use case which is not covered, feel free to let us know on the GitHub repository as well. So we're looking for feedback. Next slide. So just wanted to wrap up with some of the key takeaways from the today's session. So we talked about how you can use the centralized insight. We need log metric traces. You want to make sure to how you can innovate it, because if you don't know how's your workload looks like, you cannot really innovate and move fast enough. So observability is very critical. You can also quickly respond to the incident response. You can monitor the metrics for SLOs and performance, and overall just improve the overall customer experience. And we also talked about how you can use different observability options we have. AWS natives, if you want the simplicity, you can use more open source compatible options for flexibility and customization. And as Ella mentioned earlier, you want to make sure you instrument everything. Monitor all layers of stack. You don't want any black boxes in your stack because that can really haunt you. And then you want to treat observability as a product and automate everything. Next slide. And just to call for action, to get a hands-on experience, we highly recommend you to visit our one observability workshop. It covers both the AWS native option as the open source observability option in pretty detail. So you get all these hands-on module walkthrough for a specific use case you have. And then we talked about Observability Accelerator as well. And if you have any looking for specific best practices, highly recommend you to check out our repository on the observability best practices for different workloads you have and the skill builder. And with that, just for Q&A. So if you have any additional question, happy to take.